All right, let's solve some equations. 7 times. You know what? We've had about a 6-month break. This equation here might be a little bit too much for us, at least to start out with. Let's think about just the basics of what an equation is. So, equation, you can probably tell the first 4 letters, EQUA, they spell a word that's similar to that. It equals. Equations mean that things are equal. And when things are equal, they're the same. So I use the word equal the same as I would use the term the same. So from here on out, I'm going to say the same as instead of equals because I think it helps us get a better picture of the story that's going on in the math. And there is a story to be told here. You know, when we say that Superman is the same as Clark Kent, aren't we saying that Superman equals Clark Kent? Or how about if we had a jersey to buy and the jersey said Celtics number 0 on the front? Don't we think it's the same thing as if it said Boston number 0 on the front? I mean, it's the same guy, Jason Tatum, either way. It's the same jersey pretty much, right? I mean, we can argue I like green, I like white, I like Celtics, I like Boston, but we know the meaning behind the shirt. It's the same thing. You know, a sofa is the same thing as a couch. You might say that a sofa is a smaller couch or whatever, but they're essentially the same thing. And it's telling us a story. In mathematics, it's going to work the same way. Things are the same. When I say that 6 equals 3 plus 3, one side's the same as the other. 6 is the same as 3 plus 3. We usually just call it 6 because saying 3 plus 3 is a lot of syllables and that gets annoying. But they're the same thing. If I look at this right here, 2x plus 8 equals 12. You know, the 2x part seems like a foreign thing if you're new to the whole variable scene. And if I look at this part right here and just pull this out, 8 equals 12, that doesn't make any sense. 8 is the same as 12? I mean, is a blender the same as a backpack? Mom, I can't find the backpack again. Never mind. I don't think a blender is the same thing as a backpack. And I know that 8 isn't the same thing as 12. But 8 isn't too far off from 12. If we do some basic arithmetic, we probably can recognize that 4 and 8 make 12. So if 4 and 8 make 12, and this value right here is also the missing value right here, we can also rewrite this equation to just simply say that 2x's are the same as 4. And 2x's is really just this and, oh yeah, this right here. So x and x make 4, and x has to be the same number. It can't be like, oh, this x is 3 and this x is 1. X is x. It's the same thing. So it has to be 2 and 2. Now, you probably, when you learn this material, you got something that looks more like this. Your teacher would say to you, you have to do one thing to one side of the equal sign and one thing to the other. Hey, we're no different over here. We're going to say that exact same thing. But I think it does help to know the story behind this equal sign. It means they're the same. And I say that because students will, believe it or not, when they're all done with this stuff, they'll just accept this as truth because their work couldn't have lied. But it could have. And let me show you what I mean. You know, in a problem like this, if I add 4 and I add 4, you might say, all right, 3n is the same thing as, I don't know, 12 plus 4, 16. Negative 16. And then you divide by 3 and you divide by 3. But hang on. Negative 12 plus 4 isn't negative 16. And so if we go back to this one before things get all fractionized on us and we get confused, x is the same as 2. I need to go back in the equation, the story, and make sure it's a true story. Make sure a blender isn't equal to a backpack. So where it says x right there, I'm just going to replace that with a 2 since x is the same as 2. And we would say 2 times 2 plus 8 is the same as 12. Well, sure enough, if we do the order of operations here, 2 times 2 is 4. And if we add 8 to that, 4 plus 8 is 12. And we know that 12 would equal 12. They're the same thing. So it does make sense. But I think it's great to know that because we so often get to this step right here, and a check can take as little as 5 seconds for a 1-minute problem or 1 minute for a 12-minute problem. And yet we don't want to do that. And that to me is pretty painful to fall in that mistake. Let's look at some other stories here. One thing you want to recognize is if 9 is outside these parentheses, that's what we call the distributive property. I can distribute this 9. Distribute is just a fancy term for you're going to multiply everything in the parentheses by 9. So you're going to multiply m by 9, and you're going to multiply 2 by 9. And the confusing part is this sign right here, but since that's in front of the 2, we kind of associate that as a negative sign. So we've got 9m minus 18 is the same as 54. When you're subtracting something by 18, you're still left with 54. I can tell you, using quick mental math, that this number is going to be pretty big. Because you start off with a big number, you take some of it away, and you're still left with a pretty big number. This number right here has to be bigger than 54. I add 18. Notice I'm not just blindly adding 18. I'm trying to come up with, hey, what's going on in the story? This number right here has to be bigger than 54. These things, they cancel out. We get rid of those. And now I have 9 groups of m on one side and 54 and 18. The sum of that is 72. So it says 9 times something equals 72. Well, that would have to be 8, right? But I'm going to just prove why that is. And what your goal is ultimately in these stories, of course, at the very beginning, you have a mystery. You want to figure out what m is. And so the reason that I'm dividing right here is I'm getting m by itself because if I multiply by 9 and divide by 9, those cancel out. And I'm just left with m on one side. Whatever I do to one side of the equation, in this case I divided by 9, I do to the other side of the equation. I divide that by 9. So m is the same as 8. But are we done? I don't think so. Let's plug this in and make sure it makes sense. So I'm going to do my check here in a different color. That way we can not get lost in all the sea of numbers going on. So 9, and then I'm going to replace m with what it's the same as. Since m is the same as 8, I can just write 8 here. So 9 and then 8 replaced m minus 2 equals 54. Now, I did the distributive property earlier, and I could do it again, but I don't think I need to do that because I now know what this value is. I'm just going to follow the order of operations and say, all right, 8 minus 2 is 6, and then 9 times 6 is 54. Is that a true statement? It is. 9 times 6 is 54, and that's the same as 54. We're good. We get a match. I want to do this problem one more time, though, because in mathematics, so often the stories can be solved multiple ways. So if you recall me saying earlier that the distributive property, all it means is that we're multiplying 9 groups of m and then 9 groups of, in this case, not 2, but I would say negative 2. These parentheses indicate multiplication. If I can really summarize this as briefly as possible in as concise terms as possible, I would say 9 times some quantity right here, the whole thing, equals 54. Now, I know 9 times 6 equals 54. I learned that in elementary school. So we know that this value right here has to equal 6 because 9 times 6 equals 54. And since we know that this value, m minus 2, is the same as 6, it might be a shorter way of solving this problem out. What number minus 2 is the same as 6? Well, it has to be 8. So m is the same as 8. I got the same answer that I got over here. I just thought about it a different way because there's more than one way to interpret a story, but at the end of the day, you got to make sure that you know that Clark Kent is Superman and that a backpack isn't a binder. This one right here gets a little bit more complicated because if you try to solve the story the same way we just did, you'd be saying to yourself 9 times some value equals 4. And that's not something you probably learned in elementary school. 9 times something equals 4. But we can do it the original way. So 9 times m is 9 times m. 9 times negative 2 is negative 18. And that's the same as 4. So something minus 18 is 4. This thing right here has to be 22, but again, it's not quite so clear because 9 times something equals 22. But let's keep rolling, and let's get rid of this 18 over here, and let's add it to 4. So 4 plus 18 is 22. So 9 times something is the same as 22. Well, I know that 9 times 2 is 18, and 9 times 3 is 27. So the product, which is an answer to multiplication, has to be somewhere between 2 and 3. I'm not sure what it is, but I do know this. If, again, I want to get m by itself, that's what, at the end of the story, I want to say m is, or m is the same as. Let's get rid of this times 9. We would get rid of that the same way we did in the last one, divide by 9. So I divide by 9, and then I divided by 9 right here. I'm okay if you just say that m is the same as 22 ninths.